Welcome back. So we are going to discuss about half-range Fourier series expansion. And in many cases, we may find that the Fourier function expansion of a function is only defined in the interval 0 to pi. So to be able to find the Fourier series of this function, we can extend the interval of definition to, say, from minus pi to pi. And then once we extend the interval of definition, we can either decide to expand the series as a cosine Fourier series, or we can decide to expand the function as a sine series. So to carry out half-range expansion, the function will be defined from 0 to pi, and then the question will specifically tell you what you're supposed to do, whether you have to carry out the cosine expansion of the function, cosine Fourier series expansion of the function, or the sine Fourier expansion of the function. So once we specifically specify that you carry out half-range cosine expansion, then you use the formulas that we derived for a Fourier cosine series expansion. And if the question specify you carry out half-range sine Fourier series expansion, then you apply the formulas that we derived for the sine series expansion. So this is what you mean. So we are saying that in many physical processes, it becomes necessary to get the Fourier expansion of a function in the interval 0 to pi. But in such cases, we can extend the function in periodic manner to the interval negative pi to 0, so that the extension can allow us to either carry out Fourier cosine series expansion or Fourier sine series expansion. So when the expansion of the function is done in an even manner, then we know that you are going to result into a cosine Fourier series expansion. So if the extension is done in an even manner, such that the f of minus x equals to f of x, then we'll get a Fourier cosine series expansion of the function. But if the extension is done in an odd manner, then we get a sine series expansion. So then the extended function can either result into a Fourier sine series expansion or can result into a Fourier cosine series expansion. So note, if the expansion or the extension so we'll have f of x equals to a naught divided by 2 plus summation n from 1 to infinity of an cosine of nx. Because we are doing this one in an even manner, the bn term is 0, so we don't have the sign part. So which where this a naught is given by 2 over pi 0 to pi of f of x dx, and an will be given by 2 over pi from 0 to pi. So remember, this is how we were finding the Fourier coefficients for cosine series expansion when we are discussing about odd and even functions. So this is the Fourier cosine series of the function if the extension is done in an even manner. Case 2, if the extension is done in an odd manner, we get a Fourier sine series as f of x will be given by just summation n from 1 to infinity of bn sine of nx, since we know that a naught and an in a sine Fourier series expansion, those values are 0, So the only resulting term in the Fourier series expansion is the sine terms, where the Bn is given by 2 over pi 0 to pi of f of x multiplied by sine of nx dx. So remember, n starts from 1, 2, 3, up to infinity. So such series expansions are called half-range expansions. So note that for half-range expansions, the function will be defined in an interval 0 to pi, and the question will specifically tell you that you want to carry out either sine series expansion or cosine series expansion. So once you get that information from the problem, you know that the formulas for defining the sine series expansion is given by this in case 2, and the formula for finding the cosine series is given by formula 1. So the information will be very conspicuous in the problem itself, as we can see in this example. So the example states that represent the following function by a Fourier sine series. So the function is f of x is given by x when x is from 0 to pi over 2, and pi over 2 when x is from pi over 2 to pi. You see, this what we are defining this function from 0 to pi. And the question in itself tells us what we are supposed to do. That we are supposed to find the Fourier series by defining a sine series. And so from that given, since f of x is defined in the interval 0 to pi, we extend the interval and expand in odd manner. So remember, odd manner is what results into a sine series as specified by the problem. And we know that by definition, the sine series is given by summation n from 1 to infinity bn sine of nx, where bn is 1 over pi, 2 over pi, 0 to pi f of x sine of nx dx. N is from 1 up to infinity. So remember, the information in the question will be very clear. the function will be defined in a half of the interval that allows you to define it as either even or odd. But then you have the information whether you are going to carry out a Fourier sine series expansion or a Fourier cosine series expansion. And from the discussion on how we represent a Fourier cosine series or a Fourier sine series, you'll be able now to know the correct formula to apply. So in this case, the only thing that we take care of is the Bn, because we are only doing the sine series expansion. So the A0 and An terms are not necessary because their values are 0 when you're doing sine series expansion. Now, so Bn is going to give us 2 over pi. We are integrating from 0 to pi our function f of x sine of nx dx. But remember, from 0 to pi, there are two formulas. From 0 to pi over 2, we have x, and from pi over 2 to pi, we have pi over 2. We are going to split the so we can write this as 2 over pi integral from 0 to pi over 2. And from pi over 2, 0 to pi over 2, the function is x multiplied by sine of nx dx plus 2 over pi. Then we move from pi over 2 now to pi. And in that interval, the function is defined by pi over 2. Then you multiply by sine of nx dx. Now, the first part of the definition, we use integration by parts. So where we'll have Bn, this Bn will be 2 over pi. Now, when you use integration by parts, you'll get x into minus cosine of nx divided by n, then minus 1 times minus of sine of nx divided by n squared, and then you apply limits from 0 to pi over 2 plus two over pi, then we can multiply by pi over 2, which is a constant, into minus cosine of nx divided by n. Limits are from pi over 2, then to pi. Now, when I put in the limits in the first case, I'll get my Bn is given by 2 over pi into minus pi over 2, then times cosine of n over 2 pi divided by n plus sine of n pi over 2 divided by n squared plus the second term. When you put in the limits, we get minus cosine of n pi divided by n, and then plus cosine of n pi over 2 divided by n. So that's our Bn terms. So from which we can actually find, say, B1, when n is 1, we get 2 over pi into minus pi over 2 times cosine of pi over 2 plus sine of pi over 2, and then plus minus cosine of pi plus cosine of pi over 2. And this will give us 2 over pi. So the first value will give us 0 because cosine of pi over 2 is 0, plus 1, sine of pi over 2 is 1, and then plus this is 0, 0, and then this is, we have when you combine this, we get 1. So which will give us 2 over pi plus 1. Remember, cos of pi minus 1, so that's why I have positive 1. So this is the value of the first value of the B1 value. Now we can also get B2. So we have the answer as 2 over pi plus 1. Now when n is 2, we get B2, which will be 2 over pi into minus pi over 2 times cos of pi over 2 plus sine pi divided by 2 squared minus plus minus cosine of 2 pi divided by 2 plus cosine of pi divided by 2. When you simplify this, you'll get B2 to be 2 over pi into minus pi over 2 times minus 1 over 2 plus 0 plus minus a half minus a half, which when you combine terms, you get 2 over pi into pi over 4 and then minus 1, which is a half, minus 1, which is minus a half. And then let's get B3, and then we can write the formula, and then other things can also be found in a similar way. So 2 over pi minus pi over 2 times cosine of 3 pi over 2 divided by 3 plus sine of 3 pi over 2 divided by 3 squared plus minus cosine of 3 pi divided by 3 plus cosine of 3 pi over 2 divided by 3. And when you simplify this, you get 2 over pi into minus pi over 2 times 0 minus 1 over 9 plus a third plus 0. And on simplification, this gives us minus 2 over 9 pi plus a third. So therefore now we can write the Fourier series as f of x is given by b1, which is 2 over pi plus 1 sine of x plus b2, which is given by minus a half. So it will have a negative sign. Then plus b3, which is minus 2 over 9 pi plus a third, then sine of 3x plus other terms which you can find in a similar fashion. So that is the Fourier sine series of that given problem. So remember, to carry out half-range expansion, the interval given has to be extended. And in the question itself, you'll be told that you have to either carry out a cosine series expansion or a sine series expansion. And to define a cosine or a series expansion, just remember what we did on even and odd functions when we were discussing Fourier series on that section. Thank you.